Okay, in this tutorial, we're going to briefly consider the key question of why conduct a soil analysis. And the first thing I recommend you do is you just pause the video for a second and read the introduction to why conducting any kind of soil investigation is important. Now, the first thing you have to understand about soil is whilst there are lots of different types of soil in terms of the names of soil, and you should be familiar with some of these, for example, the brown earth, the podsalt, or the clay. When you conduct a soil study, you're more likely to be considering the actual characteristics of that soil. So the first level you can think about soil is the relative content of the three key things that make up a soil. And that is the silt content, the sand content, and the clay content. And the different types of soil are classified based on how much of each of these you find. So for example, a soil called a loam soil would have 40% sand, 40% silt, and 20% clay. And these three different particle sizes, as we can see in the photograph over here, are based on how large the particle is. So clay is the smallest of the particles in a soil. Loam, or also known as silt, is slightly larger, and sand is even larger. So if a soil's got lots of clay particles, that as a percentage, for example, a clay soil, 70% of it will have clay particles. It's going to be very tightly packed soil because the smaller particle size, the tighter the soil is going to be. And the reason to study different types of particles, first and foremost, is because it affects the drainage of the soil. So sandy soils, for example, sand being the largest of the particles, drain most freely of all of the soil types because the particle sizes are bigger and therefore there's bigger gaps between those particles. Now, why am I telling you all of this? Because when you're conducting a soil study, for example, if you were conducting the percentages of the different soil particle sizes, you're then considering, for example, in this case, the potential of the soil to be a well-drained soil or a soil that's prone to flooding. And there are all manners of different aspects to soil that you can study. If we actually have a look at the task that you're being asked to consider, is you've got to think about a soil characteristic that you could study, and then you've got to discuss and justify why you would want to investigate it. So these might be the aims of a soil investigation, but the actual characteristic of the soil, for example, its organic content or its moisture content, so how wet is the soil, or how deep is the soil, or how acidic is the soil? Is it mainly an alkaline soil or is it very acidic? You could consider the amount of biota in the soil, that's the living organisms, or any number of other things like the mineral content of different types of minerals, whether the soil's got a lot of iron in it, for example. All of these are going to influence what might be happening with the soil. So these could be influencing agricultural systems and what can be grown in the soil. These can influence whether the types of woodland that you could grow in an area or not might be influenced by the soils. This might require some kind of management if you notice that a soil isn't very deep, or if a soil is very acidic. And you might consider the type of things you need to put on the soil in order to change the chemistry of the soil. There might be a characteristic of the soil that's preventing your ability to do things with it, and that needs to be examined in order to understand that. If you examine soils over a period of time, you might notice something changing in that soil, which might be affecting the sustainability of the soil. It might be affecting how much carbon that soil can capture. It might be influencing the biological life in that soil. So it might be decreasing, for example. And you might pick that up if you study the soil over a period of time. And that might be important because if there is a change, then you have to examine what's causing that change, especially if that change is having a negative effect on whatever it is you want that soil to do, whether it captures carbon or whether it supports agricultural systems or whether it supports biological life. So think about all the things we've said. Identify a specific soil characteristics, and for each one you identify, explain and justify why you would investigate that.